So in section 8.3, we're going to test the difference between two means where the samples are dependent. Means there is a relationship between the two samples. Let me give you an example, guys. I pick 10 students, put them in the sample. I take your heartbeats before you start the test, and then again, I take your heartbeats again after you start the test. It is the same students that has a heartbeat taken before he or she started the test and right after they started the test. These groups are dependent because they come from the same students before and after action. Another example, I put 15 students in a sample. I have them, just take a test and I record their scores. Then I have students go through a review with me for like 2 days. And then I have the same students take the test again. This is an example of dependent samples because it's the same students before action and after action. So when it is the same individual, guys, something happened before some action and something happened after some action, the samples are dependent. And this is where section 8.3 is going to be about, just how to test the hypotheses for dependent samples. Two samples, but they're not independent, they are dependent. We're going to resume. So when we have two samples that are dependent, it will turn out to be a 1 t-test, not a 2-sample t-test, guys. You will see that later. Under the condition that the samples are random, the samples are dependent, paired, and the population are normally distributed, or the sample size is greater than or equal to 30. And the condition, the steps of the test, guys, no change. As you can see from previous sections, state HO and HA, calculate the test statistic T, calculate the p-value, make a decision to reject or fail to reject HO, interpret the decision in the context of the original claim. So from the example, guys, I'm going to extract the main points, and then I'll go back and put them on the first page of this section right here. So let's do this example together. Please pay attention and try to participate with me as I ask you questions. A shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer training shoes. So they're claiming if an athlete wear the manufacturer training shoes, they can jump higher. The vertical jump heights of 8 randomly selected athletes are measured. In order to measure whether what the manufacturer is saying is correct, guys, you bring some athletes and you have them jump without wearing, just the manufacturer training shoes, and you see, and you record their jumping heights. So that's what happened here. The vertical jump heights of 8 randomly selected athletes are measured. There you go. Number 1 has 24, probably inches, I don't know, 22, 25, 28. Athlete number 5 has a 35, 32. Athlete number 8 has a vertical jump. This is before they put the manufacturer's shoes on. After the athlete have used the training shoes for 8 months, their vertical jump heights are measured again, right here. You see, before and after. I could have put before and after wearing the manufacturer training shoes. Okay. This guy went from 24 to 26. So, and this guy went from 22 to 25. So it seems probably the manufacturer is working shoes here. Oh, 25 to 25 is no change. 28 to 29, improvement. 35, look at the athlete number 5. What happened? Actually, his vertical jump went down by 2. 32 to 34 went up. 30 to 35 went up by 5 points. And 27 to 30 went up by 3 points. Does it mean that the training shoes are working? I don't know. It looks like they're getting a higher number, which is good for the manufacturer, but we need to perform the test to check. Assume that the vertical jumps heights are normally distributed. That's one condition, that we have to have a population that's bell-shaped. Is there enough evidence to support the manufacturer claim at alpha equals 10%? As you notice, guys, you notice this exercise in the book, so I didn't make it up. So I got it from the book. Is there enough evidence to support the manufacturer's claim? First of all, guys, in order to test the hypotheses for two sets when they are dependent, do you agree with me that the two sets are dependent, first of all?
Yes.
Does everyone agree that the samples are dependent? That's for, you need to agree on that. Once you see a table like this, guys, be assured that the samples are dependent, because if they are dependent, the work is going to be totally different from what we did in the previous three sections. So here's what we're going to do. I already prepared the work. We're going to do the difference between the old and new. So we'll do the first one minus the second one. Can you help me, guys? 24 minus 26 is what?
2.
2. Negative 3. 0. Negative 1. Positive 2. Negative 2. Negative 5. 27 minus 30 is negative 3. I'm sorry. I put negative 30. All right. That's the first step that you have to do. Easy. It's not difficult. So you start with this step. And let me tell you why we need the difference. Okay. If, let's say I'm going to do a different example and you guys probably can participate with me. If I claim that I'm going to improve on the next test, let's say, so I claim I'm going to work hard to do get a better score, just from the previous test. So let's say on the previous test, I got 72. In order to support the claim, what kind of score should I get, guys, on the next test? So I got 72, but I claim I'm going to work so hard to get a better score on the next test. So give me a score that would support my claim. So I got 72. What do you think I should probably get to support my claim? What kind of score? 100? No, I'm not going to get 100. So let's see a different one.
75.
75. All right. Very good. Pay attention to this, guys. So I'm saying I'm improving my score. That's my goal. So I got on test 1, 72, 75. That's an improvement. I agree. Okay. Can you guys subtract 72 minus 75? What do you get?
Negative 3.
Which is less than 0. Do you guys agree that it is less than 0? Negative 3.
Yes.
That's less than 0. So I want, in order to improve my score, I want the next number to be larger than the previous number. That means if I subtract, I should get a negative answer. If you get a positive answer, what would happen, guys? What is the only way to get a positive answer in order to subtract the two numbers? What should this number be?
Lower.
Lower than 72. But I'm saying I'm going to improve my test score, so it's going to be higher. So the difference has to be negative. So improving, guys, something, you have to have a negative difference. Let me give you another example now. This semester, a student reported 12 absences. Next semester, the students promised to reduce the number of absences in my class. And let's say the students succeeded in that. So you guys give me a number of absences for the students so that we can say that he did improve from last semester.
8.
8. So last semester, this semester. What's the difference between 12 and 8? 12 minus 8?
4.
4, which is positive. So we want the difference to be positive in order to support the student's claim that his absences were reduced. And yeah, this is a good example. It went from 12 down to 8. 12 minus 8, guys, is 4, which is greater than 0. So we want the difference to be positive. That's another example of the difference. Remember, I'm comparing the difference to 0, greater than 0, less than 0. Okay, let's say a student tells me that no matter what they do in preparation for the next test, there's not going to be any difference between their score on test 1 and test 2. So if a student had a 72 on test 1, what do you expect if they say there's not going to be any difference? What do you
72.
expect their score to be on the next test? 72. And what's the difference between 72 and 72?
0.
So there is no difference means the difference equals to 0. That's what I mean by no difference. Now, I'm going to go back to this. If the manufacturer claim is correct, you guys agree with me that if someone has a vertical jump of 25 before they wear the manufacturer's shoes, what do they expect their vertical jump to be after wearing the manufacturer's shoes if the manufacturer claim is correct? Give me a
28.
number.
28.
28. And what do you expect the difference between 25 and minus 28 to be, which is what? -3, less than 0 or greater than 0?
Less than.
Less than 0. So guys, when we test the claim for two samples, when they are dependent, we take the difference and we test the difference against 0. We forget about this and that. No more. I don't need those two sets. All I need, guys, to test the difference. I mean, guys, what's the impression that you're making here when you see negative, 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 negative mostly? You should make the impression that we're testing the difference to be less than 0. So to go from a low number to a larger number, we need to test that the difference is less than 0. And this is how you state the null and the alternative hypothesis here. There are 3 scenarios, guys. I'm going to show them to you right now. It's going to take me time to finish the first exercise, but once we do that, we'll just copy and paste what we learned here. I'll explain that to you in a second. These are the 3 scenarios, and this, guys, here, mean of the difference, because we're taking only one set. We're subtracting before minus after, and we're taking one set. So, and it is against 0. Do we need to test that the difference to be greater than 0, less than 0, equal to 0, not equal to 0, etc.? So what is it going to be? So we want here the difference to be negative, guys, in the case of our question. So which one do you think is it going to be? Number 1, number 2, or number 3?
3.
You guys agree with 2 because we need to test that mu d is less than 0. That is correct. And how did I derive this? I gave you an example, guys. Be the manufacturer. If someone has a vertical jump of 25 and the manufacturer said they're going to improve, give him a number that improves, 28. Do the difference. It turns out to be negative. Yes, then we'll test the negative. And look, and I see a lot of negatives. So probably that's what I should be tested. That's another hint for us. So step number 1, guys, will be mu of d less than 0, claim greater than 0. And now, guys, it's going to be a t-test. One sample. So look what we're going to do. We're going to put the data in L1 right here. So let's do it together. So I'm going to go stat edit. I'm going to delete the 2 sets that I had before so you don't get confused with them. And we're going to enter the data from the difference. So I'll go to L1 and enter the data. -2. And for the negative sign, guys, this is the negative sign right here. Don't enter the minus operation there. That will be wrong. So -2, -3, 0, -1, 2, -2, -5, and -3. That's it. And now it's a t-test, just like in section 7.3. Go to stat, edit, t-test. And data. It's always data in section 8.3, guys, because it gives you the data. And in section 8.3, mu0 is always against 0 here, because look, I have a 0 right there, so I just put 0. L1, I put my data in L1. Frequency, never change this one. And then we need to choose the alternative, which is less than. There you go. And now I'm gonna hit calculate, guys, and watch. Okay. T, 3 decimal places, -2.33. -2.333. All right, 3 decimal places. P-value, guys, you can see is 0.0262 for decimal places. And that's all I need. Alpha is 10%. That's less than alpha, guys. Nothing new now. The only thing is new is to how to set up the null in the alternative hypothesis. Reject HO and help me out, please. There is enough evidence at the 0.10 level of significance to what, guys?
Support.
Support. Yeah, don't be afraid of saying this. The manufacturer claim. So shall we go and buy those training shoes? Probably yes, because we can support their claim. They will say it's good, but probably for athletes only. That's the tricky part right here. So there is enough evidence at the 0.10 level of significance to support the manufacturer's claim. Guys, I can give you the same exact question on the test, but you can change alpha to 1%. What will happen in this case? 0.01. What will happen to step number 3 if alpha was 0.01?
It would fail to reject.
Will be failed to reject HO, exactly. And then you say there is not enough evidence. So this is how important alpha is, guys. Alpha can determine if alpha is large, yeah, probably the p-value is going to be less than a large number. But if it is very small, then just be very careful of using alpha. So if this was 0.01, you will say there is not enough evidence at the 0.01 level of significance to support the claim. Any questions about this? So I'm going to go back now and just fill out the page that I left blank right here. Okay. So these are the 3 steps, guys. You could have this equal to 0, not equal to 0. Or you could have greater than or equal to 0, less than 0. Or you could have, guys, less than or equal to 0, greater than 0. Which one to use? It depends on the situation. You choose the one that applies. So we're going to do another question, guys, and just reinforce what we learned here. A physical education director claims by taking a special vitamin, a weightlifter can increase his strength. So these are the weightlifters, guys. Number 1, number 2, number 3, number 4, number 5, 6, 7, and 8. The name of the subject or the number it's not important to us. 8 athletes are selected and given a test of strength using a standard bench press. After 2 weeks of regular training supplemented with the vitamins, they are tested again. So this is before the training, and this is after the training with the vitamins. So the two, and these are the same athletes, guys. Number 1, 2, 3, 4, 5, etc. Or the same subjects, they don't have to be athletes. Test the effectiveness of the vitamin regimen at alpha equals 0.05. Each value in this data represents the maximum number of pounds the athlete can bench press. Assume that the variable is approximately normally distributed. Okay, so we want to see if this is effective. The training and the vitamins is effective. So this is what we're going to do, guys. We're going to do the difference here. I did them in vertical way. The previous exercise were in horizontal. Your book has them all in horizontal way just to save space. So, but it just happened that I put them in a vertical format. So can you guys help me? From 210 to 219, the difference, what would that be?
-9.
-9. 230, 236. -6. 182 minus 179, guys. What would that be? Positive 3. 205 minus 204. That should be easy. 262 minus 270. Minus 8. 253 minus 250. Positive 3. Oh, we have mixed numbers. It's positive and negative. That makes it a little bit hard. 219 minus 222. -3. And 216 minus 216 is 0. Okay, guys. Let me show you how to make the decision. I'm going to make it easy here. It's going to be either number 1 or number 2 or number 3. Look, how do you make a decision? Don't look at the difference. They claim that the vitamin and the special training will increase strength. So this is what you should do, guys. Just do this. Come up with a number. Just put any number you want to begin with. Put like, let's say 150. If after training, the strength and taking vitamin, the strength will increase, give me a number that reflects on that. So can someone give me a number that reflects on that? You started with 150. You're doing a training, lifting, vitamins to improve this number. So give me a number that has improved from this one.
160.
160. Excellent. Subtract. What's 150 minus 160?
-10.
And is -10 positive or negative?
Negative.
So you need to test less than 0 because it's negative. So that's your test. It's going to be this one. And actually, guys, you see more negative than positive. That's another hint probably for you, but you can do it just like I explained that one. So HO, guys, and HA, it's going to be mu of D less than 0. That's the claim. And mu of D is greater than 0. That's the null hypothesis. I can give you a hint, guys. Anytime if he asks for improvement, increase, it's going to be less than 0. If he asks for decrease, it's going to be greater than 0. It's the opposite of the word. So that's how it works, just with this section. And guys, we're going to put this in L1 and perform a t-test against 0, against the value 0. Okay, let's put him in L1 together. Then we'll give you a break right after this. So stat, edit. I'm going to clear L1, guys. -9, -6, 3, 1, -8, 3, -3, 0. Because we have mixed numbers, I doubt probably we're going to be able to support this claim, but let's check if it is effective or not. So you go to stat, test, it's t-test, never z-test here, t-test. Data, always data. Against 0, as I told you guys, my data is in L1. I could have put it in L2 if I wanted. And we need to test that this is less than 0, just like the previous question. And you want to draw? Let me do a draw here. It's coming. Oh, it's a big p-value. Let's see. So t is negative 1.388. And p-value, guys, you notice I don't put equal approximately because it's not exactly. So 0.1038, which is bigger than alpha. So fail to reject HO. And the conclusion now. As I told you guys, we have mixed numbers. We weren't going to be able to support the claim. So there is not. Remember, when it is a fail, guys, you start with there is not enough evidence at the 0.05 level of significance to support the claim by the physical education director. That by taking a special vitamins, a weightlifter can increase his strength. That by taking, so don't believe everything you guys you see on TV or those vitamins. You see, we did a hypothesis test here and we turned one of them down. It says that, I don't know which one is that, but by taking a special vitamin, a weightlifter can increase his strength. We're not supporting this claim. We're saying we cannot support this claim. And that's another example, guys, of section 8.3. You do the difference, you pick the appropriate alternative and null hypothesis, and just perform a t-test against 0 and do the results. One more thing, guys, before we take a break. What about if he asks, sometimes, just in the book, when you do the exercise, he will ask you to find the mean of the difference and the standard deviation of the difference before you perform the test. To find the mean and the standard deviation, if you remember, guys, from chapter 2, watch. This is the data in L1. To find the mean and the standard deviation of L1, this is what you do. You go to stat, calc, one variable is statistic. That should be clear here. And just run, calculate. And look, this is X bar. This is the mean of the difference. It's called D bar in the book. And S is the standard deviation. So X bar is negative 2.375 and S is 4.8. So if I just want to write them down on the side, this is called D bar, which is negative 2.375. And standard deviation is 4.84. All right.
Was that one var stats?
Yeah, one var stats. That always will give you the mean and the standard deviation.